Good afternoon, everyone. My name is Merle Massey. I'm the coordinator for undergraduate research at the University of Saskatchewan, and I'm the leader of the SURE program, the Student Undergraduate Research Experience program. This webinar is part of that program. This has been provided for us by the Social Sciences Research Laboratory, and Tayyab Shah is here to give us an overview, an introduction to GIS. And with that, I'm going to turn off my camera and turn it over to Tayyab.
Okay, thank you very much. Hi, everybody. Good afternoon. And my name is Tayyab, and I'm working in a social sciences research laboratory as a geospatial research manager. So I just give my background and brief before start. Years of different disciplines. So, but in Canada, mostly I'm using in a health sector. So I just want to give you my little bit background, and if let me know if you can see my profile on this Google Scholar. If somebody can let me know if they can see that. So yeah, okay, that's good. Thank you. So this is kind of the research I'm involved, and I'm actively publishing with the different professors from here and different universities. So I'm kind of lucky working with most of the senior peoples and learning from there across Canada. So in York University in Western Ontario and here Saskatchewan and Sask Polytechnic. So I have a different kind of experience where I'm publishing these kind of different papers. So, but mostly I'm using the GIS. So just want to give you a little bit background, and then we will chat about the plan. So my understanding is you guys have a some background. So I will skip the few things just to make a to having a common understanding. So as you know, we all familiar with the GIS. That's a main thing, but the main thing which I want to establish between what is basically GIS, what's the main role of the GIS we normally take. That is the link between the attribute and the features. So this is the most powerful thing. But normally we have a data which is normally stay in our database and an Excel or the Excel formats. On the other side, we have maps we usually deal with in a CAD programs, drafting and CAD. So now GIS provide a platform where we can combine these two things. We have a features and then they have linked with the attribute information so that we can use for communication purpose and some start analysis and different modeling and other kind of examples. So the real thing behind the GIS, what we normally do is having a linkages between the different kind of pieces of information together and making more powerful. So when we deal with the data, so generally we have a two major kind of data. So we call it raster and we call it vector data. So mostly people are familiar. These kind of things, I will give you some examples. In terms of vector data, we deal with the point, lines, and polygons. So I'm just moving a little bit, and I just want to give you overview. I don't want to be spending too much time on these slides, but just want to be make sure you guys are having these kind of information in your background while we are going to talk a little bit different context. So when we're looking something and all the things and like the landscape or view, so when we will thinking in terms of in the GIS point of view, we could thinking them in the point, line, the polygon. We consider those features, the lens features in our vector data point of view. So example of those is the point. You is a set of geographic coordinates, which we call the X and Y and the latitude and longitude. So then we record the point data in a single coordinate. So when we have a number of points connected with each other, that present a polyline, and that's we have some features which normally we display in polyline features like roads, river, railway tracks, those kind of things usually represent. in a polyline shape, a polyline. And polygons are basically when we have a closed polyline. And there are some examples which we have like boundaries, administrative areas, or forest boundaries, those kind of things, which we use to represent those kind of things. So so what we normally do in GIS, we when we deal with this kind of data sets, so the most common thing we are dealing with shape files. So shapefile is a group of files, which normally they have a minimum 3 files: SHP and SHX and DBF files. So these are the 3 major files which we normally connected with each other. And there's another file data storage formats which we use as geodatabase, and geodatabase has a different levels. So sometimes we use a personal level geodatabase and file geodatabase, and finally we have another level which is called enterprise level geodatabase. So you can think like you have a SQL Server database, and now you want to store the spatial data there. So we have to convert them into enterprise level geodatabase. So this is a way we have a different platform to store our spatial data, but the most common of them frequently uses a shape file, which is a Azure product. Okay, so that's the things which we have talked about the data. So so GIS is basically giving the power to connect to basically the 2 different types, vector and attribute information together. So how we capture those data sets? So normally there are different techniques we use. So this is the area which I would like to discuss a little bit more. So we know that those point line polygons, but what we normally, how we get those kind of things is interesting procedure we are involving it. So how, maybe you guys are familiar with the words, the geospatial technologies or geomatics. So these are basically these words which capture a different kind of integrated terminologies or tools and terms, like the GPS is there, GNSS is there, and image processing is there, and the surveying and cartography and like database, spatial database. So these are all the terms we normally use, how they're connected, and when we need one information connected with the other one. So for example, if we have a satellite images or drone imageries or aerial photographs, so we need to extract some information from there. So one method is, usually we do the on-screen digitization. We extracting the information as it's a kind of a labor work. We have to spend a lot of time on a manually following the features and tracing those information. And it could be the scan maps. Usually, because historically, if you look, we have the maps in a paper format, and we want to be converted into the line points and polygons. So we do the scan them and then start on-screen digitization. And in terms of aerial photographs, satellite images, so sometimes we do the image processing first and then we digitize them, or sometimes image processing is itself used to auto vectorization process. Our auto vectorization process is basically where automatically convert those raster information into the line, point, and polygon based on the nature of the features or objects over there. So in terms of the GPS, we record the coordinates. GPS is basically the main thing. They give you the geographic set of the geographic coordinates in the X, Y, Z. And we can use the GPS to get an individual location. So you guys may be familiar when you go for the field work in the different disciplines. So what you use the GPS to handle devices or in your cell phone. So to just make a point. But sometimes we use the data as a streaming. You want to continuously get a location set by every 5 minutes, set by every 1 minute, or maybe maximum you can go set every second. You can do those kind of streaming. So the GPS can be used in both. So when we have an individual location, that's usually going to be in a point format. But we have a streaming. So streaming is usually going to be as a sequence of the points, and that we use as a polyline. So where we normally use this information? So for individual location, I believe most of the people are familiar, but in terms of data streaming, when we use a GPS, is basically these days is very popular when we are tracking the things, and then there are in social science researches where the people are using data a GPS as a data logger and to continuously stream the data for tracking the kids' physical activity. So they give a handing over the GPS so they can see how active the kids are, but at the same time they can also see where this activity is being happened. So this is a way the combination of GPS and accelerometer data can give us input data. So this is one of the way how we can capture the data. Fine. And then we have another interesting thing when we have only descriptive information, when we have only our address information. So and then we want to make a set of geographic coordinates. So we usually do a method is called the geocoding process. Fine. So geocoding process is very popular in also social sciences and health sciences, where we have the address of the survey participants, the postal codes, their street address, or some, I mean, health registry data, like cancer registry data, and other. They have the addresses of the patients, or their clients, and then we have the help of those address information. They want to create a location for different purposes. So this is the method which normally we use to convert into the locations. So, and then one more last item, number 4, which is the digital image processing and the classification scheme we use. So normally in natural sciences, I can see the few people are participants are from that discipline as well. So we want to see like built up area, water body extent, vegetation. So what we know to image classification we use, but at the image classification, what we were doing, so we can use that image classification and convert them into a vector data format as well. So to do some vector analysis. So just want to be clarify here, GIS is broadly we can define into 2 major domains, raster GIS and vector GIS. So, but more, both are like in depending how you see your analysis. But I'm more talking about vector-based GIS. So when we have a raster data, which is satellite images, and we do image processing and classification. So as a result of those image processing processes, we can extract the vector data from those outcome classification process. So this is a way we can use. I can show you some examples. So this example is basically just trying to be explained the geocoding process, where we have on the top right, you can see the address. So we have a store, convenience store, and the address we know their street name and address. So that's one of the location we can identify on the Google map. And then you can see when we geocoding that, we can get the location of that. So this is a process which normally we use in geocoding to create convert the textual or descriptive information into a vector data into a point. So the main point in the logic, I'm not going to ask you to guys do any geocoding, but I just want to give you some understanding. What is the main thing in the geocoding we normally do? Is the role play is the reference data. So what we do, we have let's suppose if we have a set of postal codes, like 1,000 postal codes we have based on some survey, and we want a location of those postal codes. So what we normally do, we consult the master list of the postal codes, which had the postal code information as well as the coordinates. Those products are available on through the university websites, and other sites like Stat Canada have a postal code master layer, and DMTI is another product which we can use for as a reference data set. So it means that geocoding is basically consulting the reference data set to drive or to join or to match the location which we have in our hand, where we are going to get a set of coordinates. So this is the logic we use in geocoding. So this is one of the technique where we get the vector data. Mostly in the result of geocoding, we get a point data location of those things. So in case of on-screen digitization and map updating, so usually we know we have a high resolution imagery available, public domain, and some sketch maps. So existing information, so those information we use on-screen digitization and tracing those features and converting them into our respective spatial layers. So this is another example area where people can regularly using. So this could be example where we have historical maps and hand sketches, and you want to convert them into and field notes. You have just rough notes, and you want to convert them into a reference geographic data. So with the help of these combinations, we can capture those information in a geographically referenced format. And then another example is in this case, which I would like to share is called OpenStreetMap. So how many of you are familiar with the OpenStreetMap? Can you just let me know? I just want to see you guys are hearing me as well. Yes or no? I just want to know whether you know. Are you familiar with the OpenStreetMap, especially in their digitized? No, it's called OpenStreetMap. Okay, good. Good to know. Thank you very much. So just like Google Map, OpenStreetMap is a platform. You can Google it quickly if you would like on other screen. So OpenStreetMap is basically is a website which normally allow you to capture the digitize the data, and it's just like Google Map, but it has a different advantage. So one of the advantage is basically, if you can see on the right side, background imagery. So in the Google Map, you have only one map background, like what the Google has satellite imagery. But sometimes you have other platforms. The Bing is there, Esri word imagery is there, Mapbox is there. So different kind of background images are available. Sometimes you don't have a clear picture of the object you want to digitize, so you switch around those background images. So this platform is basically is providing you a more in an environment where you can digitize something. So I can give you the example where I use this OpenStreetMap. So before this job, last year, I was in Fiji, teaching over there in the University of South Pacific, and with like over undergraduate students. So there was a class of over 40 students. They are doing their final capstone project, and most of them individual project. So what I did, so a group of students, I involved them for on-screen digitization using OpenStreetMap. So what we did, we prepare I can show you the example. Okay, so this is one of the example of the map which we digitized using OpenStreetMap. So in Canada, most of the building footprints data is publicly available or is already developed, but still, like whenever you have a new developments, new areas coming, so somebody has to capture those information, and for you or they maintain the data set. But in different situations, because it's in developing countries, low income countries, middle income countries, how the people are using, normally the data is not readily available the way we have in Canada and the US. So in terms, you need to be understand the GIS is one of most of the use of GIS is basically capturing the data sets, how to have accurate information which you can use for your analysis and mapping purposes, which we discuss later how we are going to use this information. Fine. So the main purpose was we don't have the updated building footprints. So one of the objective was my plan was to create a building footprints for those for different reasons. I will show you those different ideas how this layer can be used in different projects and different research projects once we have a building footprint. So students altogether, they use the OpenStreetMap, and then they start digitizing the building footprints the way you can see the example on that. So this is the way we have around 3 major urban area in South Pacific. And this is one of the city is called Sua city, Sua greater area. And we have like all three areas, we have around 40,000 polygons to digitize during their lab works and their as a part of their assignment. And then that information was divided among different students to use some geospatial processes to make it more intelligent data. So why we need to do that? The plan was we want to be use this information for different reasons. For example, first we want to be add some value in it. So we want to classify these building footprints into residential and non-residential areas, estimating building age. This is important for some kind of studies. We want to know how old this building is, and then we need to be extract some related information, which is the elevation of the building, and then we have other some status of that, and then information about their name, road name associated with it, and any other house number if we can extract from other. And then more important, we can see the type of material they use. So some cases we have a high resolution images, which can allow us to extract that information as a part of attribute table. Fine, and then we can assign those information to the other areas like polygon areas, distance from the rivers and the roads and those kind of things. So it means one layer we can populate that information for different reasons. Why we need this information? So the one product, digitizing the building footprint, that's a technique we use on screen digitization. And then we using different geospatial processes to populate the data. So population means we populate the data means we are classifying the data into residential, non-residential area, building footprint size, those kind of is, there are different techniques. So each line is actually a full-fledged project. So how you will identify the classification scheme, how you will identify the age of the building. For example, if you want to calculate estimate the age of the each and every building you have here. So what we normally do, we use the image processing techniques. We will take like 5 years data, go back, and we will try to get those information when this building was appear on the map. So then we'll assign the range. So let's suppose this building was appear on the 2010, between 2010 and 15, or some building will appear 2015 to 20. So this is the way we will categorize them. So what we need a satellite images of those certain areas, time frames, and then we need to be extract the information by using classification method, image classification method to urban area and non-urban area, developed area and non-developed area. So this is the way that method will give us, and then we will overlay the polygon and we will see which building was there or not. So this is the way we will calculate the age of the building. So it means first step was to capture the building footprints. Once we have the building footprints, then we can run a number of projects. So these lines, you can see the first set of the lines, which is talking about the towards value-added geospatial layer, is basically individual projects. Right. So even there was like we were talking about 3 different cities. So one student was working on one city, and their other student are replicating the same project in another city. So at the end of the day, we can have a bigger idea, which we can experience, which we can over the 3 different cities. So no, this is the way GIS is being used for how to develop the data sets. So one, okay, what we are going to do with this kind of data sets? We have a different data, so we can use evacuation center catchment area planning for that. We can use the public bus route coverage area. We want to know how many households are within the catchment area we normally set. The same thing we can replicate in the school catchment area. So special access to healthcare services, information settlement, like the in Fiji there are some squatter settlements. They want to know how to relocate those people. So this information can be used for the relocation strategies as well. So this is the way this same product, which is one layer, which is value added by and a group of researchers by doing some geoprocess analysis, and then that layer can be used as an input for a number of potential projects where they can use. So this is the way the information, the capturing the information important. So this tool is giving you a online mapping tool where a number of students can work together. But at the end of the day, you can have a one data set which you can use for different projects again. Fine. So this is something you need to be understand how the data set we are using it. It's a lot of processes, geospatial processes involved to get that point. And then adding the attribute information in those layers are not easy. It's a lot of exercises we need to be put those kind of things. So there is another use of GIS. Normally, we collect the data on through a website in Saskatchewan. Maybe you guys are familiar with this website, where in Saskatchewan you can report any potholes on the website. So I can show you the website where is you can. Okay, let me see. So open this one. Where is that? Yes, I have another screen. Okay, so just let me know if you can see this report a pothole website. Anybody can say yes or no. Okay, good. So this website, you can open this website as well, and you can have your own experience. We can like take a little bit away from the presentation mode. So you can open this website, and if like report a pothole and in Saskatoon, so hopefully you can reach their website and let me know if somebody have a luck to get this website. Otherwise, I have address I can share with you. Okay, go out and give you this address. Okay. So you can open this website. I'm going to send this message everybody. And there is another website. I want you to open this one. Okay, so these are the two websites. I want you to guys try to be open on your screen and spend a little bit time to understand. So the main point why we need to be have this one is because GIS is going more on online. So uh, how the data is being collected. So this is one of the technique which you can see in the city of Saskatoon. They are asking the citizens or to report anything. So it means they are creating a special data. So these points are basically is if you can see. Okay, let me move this one away. Yeah, so you can see these different classification, high priority area, medium priority, low priority. So that's defined by those. So if you want to add a point, if you want to report something, so it means you are creating a special data. So you can click on the website on the point where you want to report, and then you have a different kind of information you can follow. So this is the way we are collecting the data on through online mapping tools. Right? So online mapping tools are being actively used for generating those information as well. So I believe you guys have a chance to access this website. And the other one is Planner. This is Government of Saskatchewan tool. And if you go on the left bottom, there is a home and layers. So you can see the layers. So layers are basically, you can see a number of layers are there. Those are interactive, so you can add those layers, turn on and off, those kind of things. It will take a little bit time to refresh, but you can have a experience how this information is available for the public use via web mapping. So it means GIS is doing like mostly what we do is the desktop. The software you're using, ArcMap, is basically the point of the web desktop version of the software. But this is another way we can use and share this information via web mapping. And that could be web mapping can be used for displaying the information, or as well as to collecting more information from the end users. Fine. So this is a way to, so I would like you guys to spend okay, so but okay, somebody said you're planning in Google. Yeah, brought it. really easily. Okay, anyway, yeah, there are different ways to do, but this is the local things. We have a control of different layers, which is the local layers, and people wants to be used. Most of the people who are doing field work, they want to use something. So they have actually the layer what government people are using. So they are connected with those different layers maintained by each and every department. So which is not like a case in other online mapping tools. So this tool is more reliable for the people who are working in this region. They're having a more accurate and reliable information. So now, like while I'm chatting, talking about, so I believe you guys have a chance to look around these websites and exploring a little bit more, and getting a sense of web mapping things. So there are some tools normally available which you can do the measuring, and you can draw something and you can find some data. So these are some tools usually they are for the people. So when we go back a little bit on one step and see what GIS is, and its starting point is just the combination of the point and the vector features and the attributes. And we have a huge data sets, and now we have a purpose to share. So usually we do the mapping, static maps, but now people want to be shared their dynamic interactive maps, so people can have their own the on questions and communication with the data set the way they want to see it. So the web mapping is opening a new area. So a lot of people's those in IT and the GIS related, they are involved in the web mapping development, and whereas like there's a totally new area where people are spending a lot of times via collecting and disseminating information via online means. Okay, so maybe a couple of few more minutes, you can continue to explore it. So and okay. Yeah, interesting question. You want to know how to download the layer. So normally the library is the best way to contact. You can see the layer name you want to download. You can contact to the library, GIS librarian in the university, and ask them like, this is the layer we need. So normally the library has a what's called an agreement with most of the ministries, or if not, they will contact on behalf of the students, because the students need those data for some research projects, so they can communicate and get information for you available to download it. So this is the most easy and the best way to communicate with these people, because if you individually contact them, normally they avoid it. So if you go through the library, it will be the best way the layers you want to. Most of the layers are like the transportation layers and administered boundaries, whether census or local boundaries. These are the normally boundaries that are available on our website. If you guys are familiar with the website, we have, I can try to find that information. So University Saskatchewan GIS data. So that's a page where you can go and get most of the data sets you want. Otherwise, people are there, so they can help you. So this is a website where you can download the data. So and Sarah can help you in that area to get it. So let's suppose you want to go into Saskatchewan data, so you can see the different data sets available, or otherwise you can request a librarian to help you to in access the data sets. Okay. So so now I'm going back to the presentation. I believe now we guys have some understanding what GIS data, normally the kind of things we are doing these days with the help of that. And there's some basic concepts which I would like to be introduced with you. So once we have the data, now you know there are different means of the data sets we have. So one way of the information is to display it, sharing the information via online or other public means. But there are some in between that. There's some processes which we normally do. So most common thing what we do is we calculating the distance. So the way we calculate the distance is like if you have a road network, so you calculate the actual road distance. But in case if you don't have those actual road network, or you don't want to do that, but due to some different reasons, so what other methods you have? We have a Euclidean distance, which is a straight distance calculation between the points. And then we have another way, which is called Manhattan, which is follow the grid pattern and calculate the distance based on that. So those are the approximate distances to represent the actual distance. So sometimes we need a straight line distance based on the nature of the roads we have or the objective, or sometimes we use a Manhattan distance where we have a kind of what's called as a zigzag or the grid formats, and particularly in urban areas. So this is normally show the proximity, and then we use buffers, which is very commonly we use. But there are two major kind of buffers we normally use. One is called radial buffers, the circular buffers, and the other one we call the network buffers. So depending on the objective. So where I'm using these buffers when we calculate the accessibility measures, special accessibility for the healthcare or other like food stores. We normally want to know the proximity of those in those, and sometimes we need a buffers. So why we need a network buffer? Why we need a circle? Sometimes we don't have a very accurate road network, and they have a missing patches, so it's not easy to follow the road network to create a buffer. So we use a circular buffers types. But in areas where we know the road network is very is kind of good product, comprehensive product, so we need to have a more actual network buffer based on the base of the road net. Because when we need to uh, go from point A to B, we usually follow some paths. So that paths are normally in the network. Road network is the street network is basically which provide you a you can walk from one area to other or move from one point to the other. So now sometimes to have a more actual contextualize of the buffers, so we try to be use the network buffers. So this is a whole kind of GIS. If we want to go to the network buffers, it means we are entering into the network analyst where we need to run those kind of analysis, but we have to be prepared the road networks for those kind of analysis first. So this is kind of things we normally do. And the most important thing what we normally do with the mapping with the GIS is making maps. That's you guys are expecting from this workshop. You should be able to do some mapping. But I just want to give you like a background how we get this data and how these polygons, lines, and points we using it, how what the means and methods we use to get this information, how we and populate those attributes, possible ways to handle it. So the most common thing we use is thematic mapping. In thematic mapping, I don't want to go into detail about the different types and this and that, but major thing is when we have a numeric data in continuous data, what we can do, we can make a classes and categorize our data into different classes. So here is the difference between simple thematic mapping and the role of spatial statistics. The concept between the mapping is displaying the patterns, fine. But sometimes these patterns are misleading because if you use different classification scheme to use the same to show the same data, it can show you different patterns. Sometimes you can misinterpret those patterns, like you say, it's very high and low, but it's actually the information, the classification method you're using behind it is playing a critical role over there. So that's why it's good we are using thematic mapping in most of the cases, and that's a major use of the data. But the next discussion which I want to be discuss about is special statistics. Why we need a special statistics? Where we need to discuss the special statistics is basically we need to understand how the thematic mapping is basically giving us some sense of distribution and mapping. So this screen you can see the two different classification scheme we use: equal interval and quantile, and we use the same data to categorize them. But now you can see the way we make it 5 classes, they're giving a different representation. Fine. So this is something we need to be aware while we're using a thematic mapping. So this is another way we create a map. So now I will give you a little bit examples of what kind of maps normally we use. I'm not going to be like simple nitty-gritty, but I was just give the general idea how this information can be representative in a different way. Fine. So normally we just traditional method. I just want to show you the example. So this is one of the map which I use in one of my publication, which where we have two different variables in the background. So one variable we use is the accessibility measures, accessibility score. And then the second thing is the percentage of population age 65 and over. So these two information, the thing we want to show the mismatch between them or the crosstab between them. So what we decided, let's say, okay, accessibility can be divided into two variable above and below the mean value that we can decide it depending on the researcher how they want to define the cutoff value. So we actually converted the continuous score value, the score, into two classes and adding a new attribute variable in the background of the shapefile. So we said above and below and a certain number. So we decide this value is above and below high accessibility and low accessibility. In other words, then we get the percentage of population 65 and over. So in the areas where the percentage of the population is above a national or provincial average, so we will decide this is going to be above and below. So this is the way we decided two variables which has a continuous data. One is the accessibility score. Second one is the percentage of the population. We use these two information and apply some criteria and created two new variables, and which is having information either above or below. And then we use those two variables and join together and make it above below, and below and below above. So this is the combination we can see where they are. So first row on the first value in the legend is basically from the accessibility measures. So if any area which has a poor accessibility, which is below, and the percentage of the senior is high. So this is an interesting combination which we will want to see where they are, because it means we have a less healthcare resources available for those populations that generally need a high healthcare needs. Fine. So we want to identify those areas in the map. So this is the way we use a combination of those combinations. So this combination below and above is basically the combination, the color you can see where they are distributed. So this is the way we use the map when we involve more than one variable in it. So first, normally the previous map you saw is basically a single variable where you have one variable and you can draw the map. And then this is the second scenario where we can use two variables and combine that information together and try to say something. So this is another example. So instead of making two classes above and below, sometimes we can say, okay, we can use like 3 high, medium, and low classes, let's suppose. So what you can do in that situation. So this is an example of the map where we have a three combinations. So in this case, we have, if you look at the legend, you can see the ratio, and then you can see the utilization. So yeah, I will give you some time to do these kind of mapping. The example data we have basically is you can spend some time to try these. I just want to give you the idea of visualizing it. It's not just simple traditional map. I know that different courses will normally be focused on a single variable maps, but I just want to give you the techniques I'm using to create those kind of maps. So it might be useful when you want to be in those situations when I have it. So this map will give you a combination between 3 by 3. So high H for high, medium, low. So this is the ratios. Is basically the optometrist ratio, And in the utilization of those services, it's basically we have a Canadian Community Health Survey data and calculate the percentage of utilization at the health region level in Canada. So this paper is as my new paper, which almost like its early view is available. So this map is basically the technique I use is we use three classes, high, medium, and low. I don't want to discuss like how we decided it, but the main thing is if you have a continuous data and you want to categorize them into 2 to 3 classes and how you will map them. So this is the way you can see this legend is basically draw on the map, and you can have this kind of interactive legend. It's not the graphics we put it over there. I will show you how to do that. Actually, I can go and show in ArcGIS how this map is basically see. I believe you can see the ArcGIS now. Please, somebody can say yes or no. Okay. So if you look at this legend is basically based on this layer. So turn on off means we can see basically it's a linked with it. So this layer is blinked. So if I turn on, so we can have this legend actively. So it means we can change the colors or anything we want. So how I did that is basically you can see the combinations we draw. So the things I was talking about, converting the numeric variable into the categories and then combining those categories into those combinations. So you can see the last these columns. So these are the different variables I used. So where we have another one is here. We categorize them into those categories, and then we have a combination of those categories. So in the classification scheme, if you want to do, so go to the properties, you know the properties. I believe you guys have a little bit understanding, otherwise it's not a difficult. So you can observe what I'm doing. So double click and usually go, or you can right click and go to the properties. And then under those, we have the symbology. So here the symbology we use a two combination of things. So not what I normally suggest, I can make a copy of this data and put it again. And now I can do mapping again. I don't want to disturb that classification. So I want to show you how normally is two classes we can use. So I have two classes. So we will use this one first. So now we have no classification, but those variables are we already here. We have used it. So those variables are ratio cat2 and use cat2. So I'm going to be show you how to create that the classification again if you have to be do these kind of things. Okay. So we have to be use multiple categories, and then we have a first category ratio is the ratio cat2. I just want to be try to find that one is the long list of data. Okay, where are you? So ratio cat. And cat2. Okay, so this is the one. And the other one is the use cat. Okay, so it will be might be use cat2. Yes. So now these are the two combination at the values. So we will see, and we can apply it even if you want to see. Fine. So okay. Classification. We need to be use classes here. So let me go back and have to be see what I have used. Okay, so under this, okay, sorry, I was using the wrong as a categories. Yeah, so that's not the one over there. So yeah, so is under the categories we have a unique value many fields. So there we need the two fields. So we go to the ratio cat 2, and then we have a use. So these are the categories we use it, and then we have this information over here. So this is the way you can see the classes. And if you want to see the legend of this, based on that, you will see the legend is in a different in a format. So okay, so here's the legend we have. This one. I can use a background color so you can see a little bit. Okay, so background, go to the frame, background, I will use a white background. Okay, so now this is the categories. We have 9 categories. So how we will convert into those. So that's we will go into the further properties of this legend. We need to click the legend, and then we have to go to the legend properties. So make sure you have selected the legend window, and then go to the properties, and then here into the items we have, if this is the one we have, so we want to make sure there's no label. This all the legends we are going to be turned off. Okay, the first thing is we remove those um, like the description text, and just need only the symbols. And now you can see this is the window we have, the small one on the this left side, and then we need to be the one more thing we want to make sure. Here you can see the column count is 3. So if you want to see only one, it will be give you the one list. If you want to make a 3 columns, so it means you can divide into the 3. So this is a way you can have a 3 by 3 grid. Fine, and then is the adjustment of the size. Fine, so this is a little bit work, but once you have this way, you can have a nice legend, which is the cross tab, which you can see here. So it's a with efforts, you can set the color change, so all the things. But one main thing is involve it when you have a legend, you need to turn off those text, and then you need to be make a cross tab by using a number of columns between them. So this is simple, a simple way normally having these kind of techniques. But definitely for you, if you are new, so you have to be spend a little bit time to understand how to do that. My point is basically when you see these kind of maps, basically we have a different ways to use a more than one variable, and having a way to describe that information in a way which can be more capturing more information in one map. Fine. So this is the way usually the classification. So the data set I gave you guys. So it's basically having a Toronto city, a municipality, Toronto, and it is the neighborhood level data. It has a socioeconomic variables based on the census, and we have some accessibility score, which I used for a long time ago. So that information you can, like if you meanwhile I'm listening, you can open that data, and then you can do these kind of experiment if you want to do. So that's the main purpose you want to. So you can have a chance to learn those kind of mapping techniques. Fine. So I would let you 10 minutes. I will try to be like I will stay here, but I will give you 10. You can open and try to get familiarized with the data set. So open that data set. It will look like that, and you can perform now. If you want to like follow me, it's fine. But if you want to hands-on, so I will give you 10 minutes to just bring the shapefile, and there are different ways to do that. So you can use the add button, add data, or you can use navigate up to the points, and you can use a catalog. You can mix the catalog that if you want. And if the catalog you cannot see, you have on the main menu, you can see the different options. So the catalog option, which is on and off, you can use it, and then you can navigate up to the catalog. So main thing in ArcGIS, if you guys have a chance to see in a different courses, is to go to your folder. Normally, we create a connection between the folder. That's the, you can see the small sign. It's called connect to the folder. This one. Fine. So we need to go where we have saved this data, and then we need to create a connection. So my data is saved, and then under lab and under this training. So my data is here. So I can go here and you can see my folder and I can see the shapefile. So shapefile is there. If I remove this file and I can drag and bring it here. So I want you to just um, uh, bring the data and explore different ways to having a data sets. Once you have the data and open the attribute table, right click on the name of the layer and go to the attribute table and open it. So you guys are following me, or it's too fast or something? I just want to hear yes or no, or you want me to give you more time, something. So anybody can give me some sense of is it something you would like to spend some time, or you think it's too easy for you? Okay, so you upload means you want to open the data. Yeah, I can show you one more time. So easy way is, most easiest way is, if you open the two windows together, where your data is, if you can see that file, so I can show you. So if you can see on your my computers where the actual location of the data, then you can see the ArcGIS open. Select the shape file. The different files have a name. So there will be SHP shape file. So if you look at the extension, so we have a shape file here. Okay. So this is a shape file, and take this one and drag over. Not this one. Let me see which one. So or you drag all files, select and drag and drop it here. So it will automatically load the data for you. Okay. So there are different ways to do. You can add this button. You can use the catalog, but once you have the data, and you can see attribute information. So I would like you to explore some classification methods you can use based on attribute data. For example, this variable, which is called R3 underscore 1K, is the accessibility score at 1,000 population, is like the score per 1,000 population. But you have a total population, C5 and C005 is the total population, and this information is at a neighborhood level. So it means this information is aggregated from the dissemination area and census, from the census. So then you can see the population, different variables. So then on the right side, you can see extreme. There are couples or household need a repair. That's another unemployment rate is there. So you can use anything to do the classification and see how normally you can see that. You double click on the layer name, and then you can use features, categories, or you can use the quantity. So basically we have a data which is numeric. So which we use the graduated color, graduate symbol. So there are different options we have. Population density. Normally we use graduated colors. Select the variable you want. I can select the accessibility R31K, and then we can choose different color schemes we want. And then we have a number of classes if you want a number of classes, and then there's a classification method we can use to define the classes. So here is the quantile classification, equal interval, or you can do the manual. So there are different ways to do. So I can use the standard deviation, and then we will see how the data is going to display. So this is a way you can see we have a standard deviation. So you know the standard deviation is giving you the idea, the distribution of the, around the mean, higher than mean and lower than mean. So now this map is giving you basically where the mean values are. So this accessibility score average value is in the yellow shade, and then we have a bivariant classification, which is showing two different color ramps, which you can easily understand how their values are changing. On the classification range, you actually see that accessibility scores. So against each class, which is labeled over there. So you can actual range of the classes you can see over here how they are. So the average value is between 0.7 to 1.35. And this is the average value. So any accessibility score between them is assumed as a average. So below and above values are there. So the green color, darker green shaded are areas where have more accessibility, the core downtown area and the surrounding. So this is the way classification schemes to interpret the data set. So normally we use um, in the predefined methods, but very few studies I know people are using standard deviation, but it's more meaningful. If you want a quantile, you can change, and then you can change the number of classes if you want. So if you have a 6 classes, go to the 4, you do 5, and then you can change different kind of color scheme you want to do. So this is a way you can try some things, um, like stealth. Okay. So if you open, okay, metadata. Yeah, that's a good question. Let me see if I have a Word document in it, and maybe it has some information to some extent. Yeah, so there are some variables, which is look at the table A on the Word document in the same folder. So it will give you the some important variable names I normally use it for different practices purpose. So you can go with these variables. So those access codes will you will find somewhere, and pop h and rate is population high healthcare need rate, the single parents, and is LICO is our um, low income cutoff values on home ownership. So this is the way you can use these main variables. I don't have a list of for all variables which I have in the file, but these are the major I normally use for some mapping purposes, and then some supporting variable that those used to be calculated. I hope that's okay. Great. So, and we will talk about this Word document as well, because the next I'm going to talk about a little bit about special statistics, and where we are going to actually use this data for running for question analysis. Okay. So if you guys need a little bit more time, let me know. Otherwise, you can explore how to bring the data and use one or two variable to classify and change the classes, do these kind of things. So if you want to plan, but let's suppose if you want to do, and maybe during this time workshop or later, you want to experiment the way I was showing you this map, where you have two classes, fine, above and below. How you have accessibility, you can determine whatever the score you want to be assumed as a high and low values, and then you need to create those variable, and then you can use any variable like I use here the percentage of senior population. You can pick any other variable and then convert that variable into what's called the two classes. Fine. So and then you can combine, make this kind of map. So if you want to do this kind of practice by using that data, you have the raw data there, so you can try that one. So what I normally, if you want to see the attribute table, what we have, and just to give you one example, if you want to make a new table column here, so what we need to do, go on the attribute table, open the attribute table by right click on the map, and then go to the add field. And now we can see like underscore v1, fine. And I said the show v1, and then we would decide what we need to do. So this is going to be the text if we want to say above and below, and I don't want to use the 10 length of 10 is 50 10 is okay. So now we have a new variable at the end, which is look like that. Okay. So now I want to bring this table variable in the beginning. Right click on the name of the wheel, and you have it's called freeze. So freezing is basically the bringing the table in the beginning of the this one. And now we need to find another table which we would want to use. So we can use accessibility table. Let me find the variable which we can use. Yeah. So accessibility score is the last, so we can use and freeze it too. So now we have both table columns here, and based on the ascending and descending order or whatever the method you want to decide, this value is the below and above. So what we normally do, we can do manually selection, or we can use a selection tool. And selection is by attribute and by location. By now, you know we are using attribute table, so we want to do the selection by attribute. Okay, so you guys can practice this one in a parallel if you want. Layer name, and then you have accessible score, and then you define the values that are above. So what is the mean value I have? So I'm just coming, we'll come back on this. So I want to be right click on the variable name and go to statistics. So it will basic statistics is the count minimum maximum value. So the mean is 1 point something. So it means if I use 1.03, it could be the middle value, right? 1.03. So let's see if I want to select something by that value. So here's the classification, and then we will go, and this is the greater than, and we'll go to the 1.3 something, or we can enter the value, or we can use the existing value. So 1.03. So this is something, yeah. So we can use this value, and we say the score greater than that. We can verify our statement is okay, and then we can apply, and we can select the values which is best than that range. Okay, so we have a greater than that. So greater than that is only selected values. If you want to see the only selected values, you can see in the bottom in the summary 114 out of 325 neighborhoods having this value. So we can right click on the variable which is created, and right click, and we use a field calculator. Okay, so field calculator, yes, the warning sign, we say okay. And then the field calculator is we going to put the value is called, we use a quotation in between. If we want to say something, we say above. Okay, so we know this value is above. So this is going to be assign this value in the first column based on that selected variable. So only the selected variable get this value. Okay, it's maybe, yeah, it's almost here. Yeah. So now you can see the above is assigned only where the selection is. Now we can switch the selection on the top bottom, and now we have selected the other variable. So now we will repeat the same process. Right click on the variable name, go to the field calculator, and this time we are going to say the below or low, whatever the word you more appropriate. So, but this is a technique you will use to categorize it. So now this whole range, which is a continuous variable, you have a combination of below and above. The same thing is you can do with another variable. And here we can say the sure underscore v2, and that we can pick anything, but we are going to be use the same classification above and below, and we have to be length is about 10. Now we need to find the other variable which we want to be created. I hope this is useful steps, and you can do parallel while I'm doing it, because I'm repeating the same process on a 2 times at least. So it means you have a chance. If you miss any steps, you can see the in the next one, or otherwise you can ask me if you really want to know that step. So I will go to the recent, which variable? Let's go. Single parents. Yeah. So single parents need to be click and go to the freeze. So it's going to be in the beginning of the new. So now we have a, if you see, okay, so the new variable is we created is on the end. So we need to be, we have 4 variables. So this variable is one with accessibility, and the second one is with the parents. I just want to change the order of that. Okay, single parents, we need to clear the selection. This is a button, we need to clear it. And then we need to do the sorting. And now we can see the percentage of single parents. In some neighborhoods, the population is very low or they have zero population, some cases due to some reason, and but they have very low value. And some cases, we have very high values, up to the 47% parents in that neighborhood as a single parents. Right? So it's a large number. So we need to categorize them. So again, right on the variable name and do the statistics. And now we get the mean value, which is 18.5. Right? So we can use this variable value. So I'm going to do this one because I have sorted this list by, and then we can find 18.5. This is value, and I can do click it over there and keep moving until you go and drop it here. So now you have selected. So this is another way. Last time we do the selection by attribute. This time we are just doing the manual selection, but you have to be very careful when you so make sure you have a selected variables. So we have 174 selected out of 325. Okay, so right click on that new variable, and we are saying this value is below than our mean value. So it is below it already there. So we just use it. Want to make sure we are selected the variable too. Now we have easy to switch the selection. This is the button on the main menu. Just click this one. Now you have other way around. So this, and then we can repeat the same method calculator. So this time calculator is working on the selected value as well. And then so now we have actually categorized our two variables into, and so you learn this process, how to create a new variable, how to select the things, and how to use a calculator to do that. And you can do the statistics. So this is the way normally I use a combination of things to quickly do that. Rather than asking you to read the whole instruction, you just need to understand the logic, and then it's the similar the other software we use it. So now our two variable 1 and 2 is ready. So now we need to go for the classification. So when we see the classification between them, I hope you guys are following me. So now the double click on the layer name. And the categories, because now we have not the continuous data. Before we have a continuous data, the percentage and the score, then we use the quantities to categorize variable normally we use, or we can use the rates or those kind of things, and the number of classes. Fine. And then we have a classification methods. That's you can go through what the method we have. But this time we have converted this data, which is continuous data, into a dichotomy. We have two classes. So we go to the categories and we use the unique value fields. And then we make a combination. So we have V1 and the other variable name is V2. Right? And then we have populate them. So now you can see the combination between them is there. So just order of these things is based on the order you selected over here. The first field is V1. We know the accessibility score. V2 is our single parent, percentage of the single parent. So it means we know the combination. What is the meaning of that? So we can use different color combinations, and depending, you can pick the color you like, the way you want to see. So I would say, like, if any score is below a low access score, and then we have a high percentage of single parents, because usually single parents is difficult to manage the kids, like going to the family clinics, see the doctor. So if doctors are close to your place of living, it means you have a benefits. You can easily access those healthcare services when you need it. So it means this combination, high percentage of the family physician, high percentage of the single parents, it usually they need a more healthcare services. So on the other side, they have a low accessibility, means that they have a comparatively less number of doctors available nearby in the service. So this combination is highlighting those neighborhoods where usually they have this kind of tough situations. The parents are usually the single parents are a large number proportion, and but on the other side, healthcare services are comparatively low as compared to other part of the city. So this is the way this map can be displaying some information, and you learn how to do the combination of those maps. Okay, so if you are trying to follow those steps and trying to do your own, so just let me know if you need more time. Or you want me to spend some more time on this one and you want to explore any step you want me to repeat it. So just please let me know. I'm still waiting. Okay. Good to know that. Okay, so okay, let's like nobody wants to say something about they really are following these steps or not. So meanwhile, I wanna talk about a little bit about when we need to do these kind of mapping. So my understanding is you guys are researchers, are going to be a future researchers as well, having involved in different research projects. So it means you're going to be do some publication at different stage. So it means when you do the mapping, so we need to understand why we need to do the mapping. What is the main purpose of the map? So sometime you want to have the data you want to show with the people. So web mapping, you have a chance to see the two examples where you can share your geospatial information with a larger audience, but using a web mapping. So, but for the publication point of view, or reporting, publishing, or some poster point of view, you need a map. Fine. So classification is the things we discuss is basically is how you how to communicate with the data, how you transform the attribute information into a map. But no, map layout is another important aspect of the mapping, which I would like people like to see. So now these examples are basically, this is the one map you can see. This is another example of the map. You can see the different layout. You can see the legend, north arrow, and these kind of combinations. So how how you can easily develop these kind of map using software. What those windows, you can see the main map is on the bottom, and then they have a three windows, and the three windows are, you can see those the location of inset maps are basically you can see on the main map. So it's easy to understand how the maps. So window sizes are looks like equal, similar size, and so how you can do these kind of things in ArcGIS. I just want to give you some tips. So while you are in the ArcGIS using this map, so whatever the map you finalize, or a single classification, or you want to cross tab, so whatever you have, so you want to go to the map layout. So on the bottom, you can see there are two tools. We are in the maps window, but the other one is a, if you switch around, you can see the map and the layout. So this is something you need to understand. So if you guys are following this step, and you found this layout button and like look like this way window, so please let me know if like just want to see the yes or no. Okay, that's only one person. Any other wants to say something? Okay, good. So it means we have now I want to talk a little bit how you can make the map look like those kind of examples which I'm sharing with you, and there are others too. So what normally the techniques we are using it. So first thing, which normally based on my experience, what people are missing is the map size. Fine. When you look at the manuscript guidelines, author's guideline, they specifically mention the page size, figure size, map size. They allow you to submit. Otherwise, they cannot accept it. So what we need to do, we need to understand how to change the map size. So we go to the map page, file and a page and print setup. And then here we are going to set the map size. So whatever you do, whatever the printer or something, PDF is not going to be a big thing. But what you need to do is basically look the option we have underneath. I will go to the PDF. Then we have this printer page setting and uncheck this one. And now this is open for us to change the size of the map. So we will change the inches, unit in the inches, and then look at the 8.5 inches by 11 inches by default. So normally when you have a report, paper, anything, you have A4 size paper, which is normally 8.5 by 1 inches. You cannot insert exactly the same size of a map in the same page because you need a border, 1 inch is border from all sides at least. So it means actual map size is smaller than is our paper size. So that is the logic. So when you will look at the author's guideline, usually they said the map size which should be around 7 and the height is around 6 or 6.5 something. So this is the combination that normally allow you to have a margin option over there. So what first we do, we set the map size. We know what exactly the size we have. Click on the window frame and resize it and try to fit in the layout size we have. Okay, so this is the way we normally do. And then we use right click on the map and zoom to extend, make sure map is, we can see the maximum. So that's the first step. We want to make sure our map is designed, starting from the design based on the outlines we have. So it means usually if you want to publish in the report, you want to use in the report, you want to use in the manuscript. So usually the requirement is like that. So I can give you the example if I export this map right away, and I will see this one. Okay, so you can follow these steps if and then save this map where I want to go to my folder. So map 1 and just save as. I need to repeat that process just to want to show you the what is called the file format I choose. So it's EMF. So I want to go to the JPG and again map 1. But this time it's the JPG and I want to change the resolution. Normally for the print purposes, they needed 300 to 500 dpi for the JPEG or TIFF file. Okay, so this is the way I can see the JPG. Okay, so this is a file I exported, and now that map here in the document. That's where we're going to use it. So we can use this drive. We go to the location where we save this one. And then, okay. So we have this. So this is the JPG format. We insert it. When you insert it, this is the by default size. So if you see the by default size, double click on, so you can see the size is 6 by 7 inches. So we have not rescaled this map. Fine. If you want to, like, sometime you want a small map, let me move it to the next page and focus on this page. So if you resize and double click on the word, and then you go to the size and position. And here you have so reset will give you the 100% size of the map as per design in ArcGIS. So this is the way map is actual size of the map. Fine. So if you have a map design A, it's not going to. You are going to shrink the map if you want to fit on the paper. So that's a basic thing we need to learn when you design it. What we need to consider. We start from the page layout. Fine. And then we need to be planning to use our maps where we are going to be insert maps and those kind of. I'll go quickly to show you a few things which normally we do. Rest of the thing you can explore in the layout what you need to do. So So if this is if the layout, so what I normally do, I use these controls. Fine. So if you click on the border, if you cannot see the border, you can have to go to the view, and then you can see these status bars, control bars. So these are the things, rulers, you can turn on or off, but I usually leave it there. So then the guides are there. So these guides are basically as working as a magnet. So I need to be make sure my borders are exactly the same. So what I normally do, I have select this one, and I suppose select, and then go to the drop. It will automatically magnet it. So it means our map is going to be having a equal border size on all sides. Fine. So this is the way you can use these magnets, guides. So this will help you to design a nice layout of the map. So I usually not leaving that much space. I've used very small space. So what I right click on the border on the ruler, and then go to the options. Options, we have a way to have a more spaces between them. Right now, layout view, and it is a 1 inch, 0.1 inch is the interval we have. So we can increase the interval. So we can do 0.01. So now you can see on the scale, we have a more options to have a more better interval. So we can do a little bit, if you can see how much the interval is. So this is the both sides, zoom whole page, zoom page. This is the layout option. Same thing we can do, get to this one, and we can use this one up to the this. So now we know the exact location of those guides. So now we need to change that tool, right selector, and just move this one to the those gates. If I have a double one, yeah, just drag and throw them outside it. Okay. So this is a way you will see you have a borderline, nice, and then and the north arrow. These are the all things you can do. You can do. I don't want to be discuss this one, but I want to show you if you want to make a two maps. So you just copy this map, select this one, copy, paste it again. Now you have a two windows of the same map. So select the recent window. Now you can see you have two what's called is we call it let me see the data frames. So you can say the map one, and this could be the main map. Let's see which one is the main map or not. So if you click here and you see the color, one is it bold or not bold. So this one is bold. It is this map is this one. So we can say the rename it, and this is our inset window. So we can set inset map. Okay, just to identify. So now we want to move this map a little bit on the bottom and make a room for the other inset map where we can fit in. Okay. We can see if area we cannot show on this map. Clear the selection, and we can use a smaller window. And now these two maps, we need to connect, make a connection between them. So inset map is going to show on the main map. So inset map, double click on the properties and go to the what's called is the extend indicators, and main map is there. So we put it over there and select the frame, and just want to go by the default. We can see those things or not. Okay. I think I wanted to do the other way around. I did, but yeah. Okay, yeah, so we need to do the other way around, sorry. So we have the main map and showing the unset. We need to do the same process again, but and then select the frame. I can change a little bit lighter and with some other color. Okay, so now you can see this window is actually showing the extent of this map. So if you want to zoom this map somewhere, so this window is automatically changed. Okay, so it means now you want to go to show some area which is very high dense area and which we cannot show. This is the way we can use the inset maps. Okay, So if you want to use inset map another one and one this area, one some other one, so what we can do, copy this inset map, paste it again. Now we have another window. We can put it here and resize this window, and we can move this window where you want to go. Fine. And now, because this map is our new map, which is our map inset map 2, so we have to go back to the main map, go to the properties, and this an extend indicator, go to the map 2, which is not there, and then we can select one by one. So select map 2, data frame. This time we are going to use the data frame maybe with a different color. So let's a different color. So now you can see the location of two maps, inset maps are there. So you can move the one map, you can see. So this is the way you can use a map. And now you can imagine this map, which I was showing you, this is basically designed in that way. So where we have a main map, and then we have three inset maps, and those are the windows I designed. Three windows, and the way I arrange it, basically, I see how much information I'm going to show, and decided two different sides of the windows and adjust them accordingly. So this is the one layout, but everything is designed for the final. Fine, and the layout size is basically decided based on the journal's requirement accordingly. Okay, I hope this will be helpful to if you guys have a little bit understanding in the. Okay, so so I can spend some time and show you the repeat of some steps. So the main purpose is basically you guys know the north arrow legends, those kind of things, how to add those kind of map. But the major thing is if you want to have a multiple maps, you want to add different things. So how you will do quickly, and the window size like the base or main kind of thing. So the major thing is if you see over here, if I am here and if I want to drop this one magnet, so this window is our corner of the map. If I select, you can see the selection. And if I take it close to the window intersection, it will be exactly overlapped. So it means if I'm not using this one and not this one, and I'm trying to do the same thing again, so now I have a difficulty to drop the map. So sometime this way, sometime if depending on my zoom level as well. So if I'm doing this one, let me do it. It's very difficult to place a map and over there exactly. Your chances are there. So one side is wider and another. So this kind of differences you can see. So how to do that? So normally click on those rulers of view. So these are the control panels in the layout. You can display the some things or so, but what you need to now you need add the guides. So you just click where you want to do that. If you want to do it, then you can move it. So you can see on the corners how exactly you want to move. The same thing you can do, and you can move where you want to drop it. So it can only move when you have an interval in between. So right click on this particular space, then go to the options. You can change the intervals if you want. So by default is a comparatively large interval. So now if you go to the ArcMap options and under the layout view, so now you have a rulers show the values. So right 0.01 inches interval, the smallest interval between two. So you can change in 0.05 now if you want. And then you can see this interval is refreshed. Fine. So now we have only intervals of move in between the two intervals. This guideline. So you can have 0.5 now, and everything is 0.5, and we readjust them. We have like over here, and then the same thing is we select this one and want to make sure they are using the new guides. So this is the first thing, like you need to be understand, you need to be exactly the same. And then we have, yeah, and other one too. So on the bottom, so then we can have all sides are equal. symmetrical. It's called balanced. So this is something you can use this one. If you drop there, you are sure 100% they are going to be intersect on the same location. The same thing is you can do that. Okay. So if you want to use the same, okay. So I hope that's clear now, Sarah. Okay, so in some cases you want to have a exactly same windows. Like I like this window, let's suppose I want this window be exactly the same size. So what I will do, I select this one window first because this is my target and this is my reference. I will use and select this one. So now you will see the both will have the selected, but they have a different color. It's slightly green and it's this cyan color. So green is our target, cyan is our reference. So right click on one of them, either this one or this, and then go to the distribute. So here is the window size you can control. So what you do, you want to target size exactly the same of the reference size. So we want exactly the same size, make same size, fine? So we will do that, have the two windows exactly the same size, overlap it, fine? So this is the way you can have a multiple windows, fine? And if you want to do one more window, just need to copy this one. Now you have another window, you can put it here. So now this window is new and which is not reflected on the map. So what we can do, we make the change of a little bit area. And now we will try to be add in the main map, which is, we have to rename it first because this is a new map. Okay, so if you want, and adding the frame, and this time I'm going to with the by default values. Okay, so now you can see the three windows. So now another challenge is how you want to overlap these. Okay, corner, but if you want to, these windows has to be exactly having equal interval or something like that. So what we normally do, we use what's called is the right click and add another grip something. I will show you. Zoom this one and go here, add a new control and go back. And just now, you know, you have another corner of this intersection of these guides is going to intersection. So it means you are going to exactly overlap these two windows. So now you can see their map is exactly overlapped. Okay, so this is a nice and clean map. So I'm going back to the example which I was talking about. So you can see the windows I have here. So exactly, I usually do try to be those kind of things. So this kind of things. So another thing is interesting when you draw the maps, which overlook is, I will show you the examples. And then I have these maps. So please let me know if you can see this statistical area classification map. Anybody can say yes or no? Okay, good, thank you. So this is a one map. Now, if you have more than one map for the same paper, for the same report, how you handle it? So if you see my map, these are showing you, but you can see the transition from one map to the other, it exactly overlap, but the window frame design is same, but only the content, fine? But the basic design is similar, like you can see the overlap. And another example is this map. You can see this map, and I have this map is utilization, ratio versus utilization, then is a senior ratio, and then another one. Now you can see that all three maps are having exactly kind of same layout. Most of the things, if layer main information layer is exactly on the same spot, other than the classification and the little bit labels and those information are slightly changed. So this is another thing when you're dealing with the mapping using GIS, you need to be understand how to make these kind of maps. So what normally we do, when we finish this ArcGIS save as, we need to just save as a copy. It means we have our map, and then we start the map without changing anything. If you change if you use this tool and you have changed this one here, So you have a option to undo that. So let me show you. So if you change the area and then you have option here, go back to the previous extent. So we can do that. So this is the way we can get the same exact position, which manually we can do that. But there is another way we can bookmark this location, which is very interesting feature. So if you bookmark this feature, I can create a new bookmark and I can say the bookmark and save it. And now I can zoom in or something like that and have this map here and there in the layout. So now I want to go back exactly same location. So just want to go back onto the bookmark I created, and it will give me the exact same location of the map. That means when we make a number of maps, but when you every time when you want to make some changes in the map, the chances are there you can change the location of the map in the layout. So it means you get the same location again, so you can do the back to the previous extent, or best way is to use a bookmark, save this location, and then this is the way you can retain the exact map. So whenever you have a final product, so when you will look at that, they are going to be look like a designed by one person. Okay, so these are the few tips. I will. So now let me know if you have any questions, and you really want to see any, want to repeat it before going to do the last. Anybody has any questions? Okay, so back to the access data set. So I will go back to the main map, activate, and now we have the main map, and I can minimize this one. So what I need to show you guys is basically where's my PowerPoint? Yeah. So in GIS, there you need to be aware, particularly when we aggregate the data. So the information you was looking in is based on a neighborhood. So this is the neighborhood map for Toronto, but this information is actually based on the dissemination area, DAs. So it means they aggregate the information. So normally when we do the aggregation, so we are dealing with the modifiable aerial unit problem. So there are two kind of things. One, we have a actual layer, and then we regroup them to the smaller, larger units. So which is called scaling option. So scaling option, you can say the dissemination areas region is 864 DAs, dissemination areas. But when you look at the census tract, they are 125. It means that they have larger units and less number, small number. Then we look at the neighborhood, there are 32 neighborhoods. It means there are larger units. And again, if you look at the number of wards, there are 11. So it means this DA had the, if you want to aggregate up to this level or other levels, so you're dealing with a scaling issue. Right? And if sometime, if you let's assume the census tract and neighborhoods are, in some cases, like in Saskatchewan, they are very close, same number of units, similar number of units. So it means they are presenting this zoning issue. So they are basically the different scale, but between them is a similar number of zones. So if they have exact or close number of zones, they have a zoning issue, the way they are regrouped the data. So it means sometimes the 5 dissemination areas converted into the census tract, but the other time neighborhood, they will be the use other 5 DAs, but maybe the mix match between them, but not exactly the same 5 DAs which they use in the census tract. So it means the grouping is different. So outcome number of variables are same, but the way they process is different. So that's called a zoning. So you can see the example. Another example of this one is normally we use in census subdivisions and census consolidated subdivisions. So in Saskatchewan, 959 CSDs, and there are 300 census subdivision based on 2016 census. So it means this is between them is a scaling issue. So there are two different scales. So when this kind of data is there and you want to do some statistics over there, it means you are going to be treated with data. So then what we can be happen, you can get a different kind of outcome. So one of the example, when we aggregate the dissemination area level data, for this example is the accessibility score, aggregated up to the census and consolidated census subdivisions. So you will see the results are different. So it's the same score, which is low score, a different range of score, but the percentage of the scores are different in different unit of analysis. So it means when you use the statistics to predict something, you're not getting the exactly outcome variable if you use a different unit of analysis. So whether you use a scaling approach or use a zoning approach, it means you are dealing the same data aggregated differently or at different level of aggregations. In either case, chances are there you could have a different outcome. Outcome means your prediction could be different, your estimates could be different. It means whatever you're predicting, whatever you're modeling, whatever you're trying to say is it could be influence your results. So in GIS, we need to understand when with this kind of situation. Why we need to do that? Because mapping is not sufficient. The thematic mapping is normally we need to go beyond, and that is called special statistics. What we can do, we can use for the measuring geographic distribution, special patterns, special regressions, and we have other methods, including the special interpolation technique. These are the examples where we can use the special statistics. Fine. So one of the example of the special statistics is we use a special autocorrelation. Autocorrelation can be used in two different ways. One, to see whether the variable is randomly distributed or not. They have a cluster in the data or they have a random distribution. So this is important. If you want to know uh, like accessibility score, or in this case, we have a what we have on the variable recent immigrants. So where the immigrants are trying to be stay mostly. So this is a simple thematic map. We have a classification on the left side. But when we do the clustering, we're using statistics, we find a significant clusters where you can see the red color high, high, which means high of recent immigrants surrounded by the neighborhood where have a high percentage of the immigrants. So it means they are presenting a clusters, right? So we want to know where exactly the most recent people, immigrants, they want to be likely to go there. Fine. So this is the way this map will give more kind of information beyond the thematic map you use it. So this is the combination. So the statistics is basically the confirmation of the patterns by using a statistical diagnosis. So we can use GIS for we can enter into the special statistics, special analysis, where we can use this kind of example. So back to your data. In this example we have, and then you can use the same example if you want to practice yourself. You can go to the tools. You know how to get the tool. The red button is there. If you're not there, you can click this one, and there are different ways to access this toolbar. And go to the second last column, most probably in my case, but I don't know what exactly the location of this column is. It's called special statistics. And then you have a different options, so like the mapping clusters is there, and then is analyzing the patterns. So they have a different tools. I would like to see the first one is in under the mapping clusters, which is called cluster and outliers. So this one, and we can use the variable we have, the layer we have, input variable we want to be see the distribution is our accessibility score, which is where is that? Yeah, access score is the last column. Fine. And then we want to be stored somewhere. I just want to be to go by default. There's some method of relationship defining it. So we have a different contiguities. We can use contiguity edge and corners, and then standardization. So these are different options. You can see that when you click it, you can have a help. You can open the help. by show and off. So this is a very good tip you can do and but use it by default. And then you can see this this kind of analysis is running on the bottom, and then you can go back and wait when it automatically added a new layer of having a cluster information. Fine. So this is the way you can run this, use the same data, and you can apply this a technique and see whether you can have some cluster information in this map based on the accessibility score, which is we call it access to family physicians. And that's usually we do the number score is basically representing the number of physician per thousand population. Fine. So we usually will see some fractions. It means it's showing you the number. So this is the way you can see this score is basically giving you the cluster. So it's not showing any high clusters, in other words. Fine. So, but they have a low clusters, low values of accessibility surrounded by the low values. So this is important. Fine. So these are the two parts of the city normally where if somebody is living in these neighborhood, they will have a hard time to find a family physician. Because the accessibility score is low, it means availability of the physician in these neighborhoods will be difficult for them. Fine. That's a confirmation of low values surrounded by the low values neighborhoods. So this is the way you interpret it. So there's some the outliers kind of situation where is the low value surrounded by the high and high value surrounded by the low value. So this is the way we use the statistics to interpret. And if you want to see the results of this method, we can do geoprocessing method, geoprocessing menu, and then there will you see the results. You go to the results, and then you can see the current session, and that's the most process you use. And here you can see the result of this under the message. You can see something which output file is there. You can see the add into the table, and then go to the, and here you can see that table. Where is that? It should be somewhere. Okay, it's not showing me, but usually we can see that attribute table here. Open it and anyway, but my point is this is the way you can have a special statistics. You can enter into the special statistics. I just want to touch this one. So this is the way you can have idea about this. There's another study just from the example of a study in low birth weight babies prevalence in Georgia and US. So you can see this is the way that they use the same tool, and it's published in a paper over there in 2012. Is it a good journal? Applied Geography is a good journal. So this is the main process they use. They have a low birth weight. They calculate the prevalence and showing this data and using the LISA method, the local what's called as the cluster maps. So which is you can identify the high and low values. So in this case, low birth weight prevalence, if it's a high prevalence, it means there's a more low birth weights. So it means high clusters are important in that case. So you need to understand, sometimes you need a low clusters important, sometimes high clusters are important, and sometimes you need a combination of those. You want to know where is the high value surrounded by the low values and low. So that's is basically giving you the statistically based confirmation of the data. Okay. So this is the way of statistics used. And then another way of the statistics we use is local regression. We normally use a regression, but geographically weighted regression is a way we can see. It's like a little bit, I would like to touch this area because for the research point of view, it's very important. And normally when we use that linear regressions and when data have this kind of patterns, so this dependent variable, low birth weight prevalence, is telling you the data is clustered. So clustered means it's evidence of the cluster is there. So it means data is not randomly distributed. So it means one of the assumption in the linear regression is data should be randomly distributed. So it means your linear regression is violating one of the assumptions, which is very important. And this map is telling you the cluster, presence of cluster mean data is not randomly distributed. So when you have this kind of situation, you cannot believe your linear regression results. without having some further investigation. You have to be very careful because you could missing some important predictor in your model. Maybe you have the relationship is wrong. Maybe the power of the coefficient is different. So there could be different things contributing towards that violation. So it means if you're ignoring that assumption and you continue to believe on the linear regression, you build it. So it means you may be having a misprediction. That's why when the policymakers are using modeling, and if the models are not built and not reliable, it means the prediction is going to be could be wrong after 5 years when they start funding and try to be follow the model predictions like you do this and that. So it means they maybe ended up like having a wrong indicator, wrong variable, which is not actually the predictor variable, but you assume it's the predictor because of the wrong prediction. So what we need to do, we use a linear special statistics regressions to fix that problem. So this is the way we have option to the linear geographically weighted regression and other areas of the regression. So I think I will leave it here. There are a lot of things to talk about, but I want to just give you the GIS is basically what we started from in the beginning, which is we talked about the relationship between the both things, which is okay, come on, where is that? Where we talked about the relationship. So this is the main thing you can see. When you have an attribute information behind the feed, that's become the power. So now you can run the statistics. That information is there. You should be aware of the variable you are. You need a raw variables to calculate the prevalence, percentages. You need to know, understand those kind of things. And then you can go beyond. So you can do the thematic classification. You can use layers into the web mapping. You can use these layers for the special statistics and building different regression models and those kind of things. So please let me know if you have any question. I hope you guys like have a chance to do a little bit hands-on, but data is there. Some ideas how the statistics can do. So there are a lot of toolbars there, so you can go and explore those kind of things and have a chance to build those kind of things. So hotspots and grouping analysis there. And if you want to do the regression, so here's the geographically weighted regression you can use. So when you go there, good thing is the help is there. The help is very powerful tool is over there. So if you understand how to input the feature, dependent variable, explanatory variables, so you can do this kind of things easily. So the exercise we have here in this data set is basically you can run this special autocorrelation, and I have pointed out the few variables if you like to do. It's part of some lab exercise I used to run. So I just use this information if you want to do. So you can follow this document. You can produce few maps. And how you want to lay out the maps, I hope you will find it interesting to map the layout and control different things. And the examples will be also giving some ideas how the cross and different variables can be used to display information. Okay, so any question you guys have, let me know. I think I have done.
It's absolutely fascinating, and there's so much information there. Hopefully everybody can hear me. I'm getting some feedback on my end. I had a quick question, Tab. So I was going in through ArcMap through VLab, and one of the things that I discovered is that if you don't have your data downloaded, like the data that you sent, if you have it downloaded on your personal computer and then try and access ArcMap through VLab, it doesn't actually work. You can't access the data that you sent, like if you downloaded it onto your personal email. So one thing that we do need to find a way to do is the data that you shared
yes.
is to share it onto your U of S.
Best way is, sorry to interrupt you.
No, no, go ahead.
Best way is to go to the pause and go to the my folder, and you upload the folder in your cabinet over there.
Yes, exactly. And
so
that's
go
perfect.
to the cabinet, and then that cabinet, I right now the VLab. So I have copied that my data in my cabinet. So it's only thing is you need to enter into separate window, go to the pause, and then folder where you can see the personal, and then there will be option where you can communicate with the data.
That's right. So you can upload the data to that, and that will solve that problem. So that's perfect. So I just wanted to kind of walk students through that in case they got stuck there, like I did. I did figure it out, but it's good for you to explain. A couple of other things. When someone logs into VLab, there are multiple options. There's ArcGlobe, ArcMap, and ArcScene.
So you're talking about this window options if you're on the screen. Fine.
That's right. If you're in VLab, yeah. So there's
Yeah, so
ArcGlobe,
basically,
ArcMap, and
yeah.
ArcScene.
So we use ArcMap. Fine. So we have a two different version of ArcMap, 10.6, 10.7. Sorry. So then these are the other options. Our catalog, we have part of the ArcMap, but we can have an independent ARC catalog. Our globe is for the 3D modeling, and also 3D maps. So these are when you have a really, you want to make some landscape or those kind of things. So these tools are basically, these options are best for that. So
That's what those are for.
most of
Awesome.
the thing when that's one mostly what we do for the data processing, cleaning, and mapping. So we use the ArcMap.
Yeah, Sarah says, I found for doing my summer research, the VLab doesn't work well at all. It has limited functionality, particularly for starting to do modeling. I found the ArcMap desktop download is better, and you can get a license from the research computing support staff. Absolutely, you can. So you send an email to IT, tell them who you are and your NSID, and ask them for that, and the university will allow you to download that right to your desktop.
So, and if you guys want to learn a few things, new things, I will suggest you guys Esri account, create your account. It's called, let me see if I open that one. I was looking something over there. So in Esri training, ESRI training, so you can go there and basically, let me see where is my training is. I will actually open that one for share with, no, it's not. Yeah, no, it's not there. So, but anyway, you can go to the Esri training. Yeah, it's here. Sorry. Yeah. So, create your account as Esri Academy there. Create account, and because use your university email, so you will have a option which is called maintenance license options and the free software training. So you have a number of trainings which you can use. So if you want to do quickly, if I want to show some training, which I can do the freely. So just enable this one. And if you want to do the get started, so you have only the trainings, and then you can go to start with the ArcGIS app, and with I can change the product. It's called ArcMap, and then we have the training which is related to ArcMap, and which we as a university student we can see. So if you want to do the basic coordinate systems, let's go. And it's 2 hour 45-minute training, and then you can load and add in, and you can run that training on your own. And then at the end of the day, you can have a certificate from the Esri, which is that you have done this training successfully. Okay, so there are a lot of things free for as a student. You can learn a lot of things.
That's fantastic information, Tayyab. Thank you so much. Does anyone else have any other questions? You're a very dedicated group, but a quiet group. That looks great. Wow, that was amazing. That was a fun afternoon and a great way to spend a couple of hours. I admit I was lost a couple of times, but that's okay. Sometimes it takes a few minutes to just go back in and think, are you available for appointments at all?
Yes,
Sarah is asking.
you guys know in SS, so we are here for the researchers and the students. So if you have a like quick question, like you want to chat something, most welcome. You can come or you can call me. If you are on a team using team, you can give me a call. It's easy to give you the tips like what you need to do if you're stuck somewhere, or if you want to discuss your research projects, or if you want to discuss anything how you can use the GIS in your project. Welcome to contact me by any means. You know that you're smart people. You know how to reach me. So my information is there on the SSR website. My personal number, email, and Skype, and everything is there, so you can find me the way you can easily find. So most welcome. I love to work with the students. I usually publish the paper with them. So if you look at my portfolio, I show it in the beginning. So most of the papers are with my other undergrad and graduate students we published together. Fine. So this is a recent paper is with Makila is published in Canadian Geographer. So we have and Professor Scott Belt. So this is actually that undergraduate students that publish in a Canadian Geographer, which is like 1+ impact factor journal. We have a nice paper over there. Fine. So I love to
Nice.
work in if resources and the things you have to discuss. Okay.
Thank you also very much, and thank you very much, Tayyab, for being with us today and sharing your time and your expertise. It's very much appreciated.
Thank you. Thank you
I'll
very
close
much
everything
for
off and end the recording. And thank you everyone for coming.